You've already drawn it? Okay, this is an exact question that we would have done in grade 11 pre-calc. So you have 1,200 meters to enclose 3 rectangular pens. So it's that one, remember it? Can you give me some L's and W's on your diagram? Okay, I'm going to put the top and the bottom sides with L, and then W doesn't matter if you did it the other way, we would get to the same in the end. Okay, so all of that is the fencing, so 2 L's plus 4 W's would equal 1,200. We're trying to maximize the area, so the area equals length times width. Area is squared, which as a function will be quadratic, right? Does that make sense? I can't have a quadratic function with 2 different variables. So do you remember what the strategy of this problem was? Isolate and then substitute. So which letter do you want to isolate over here, an L or a W? L. Pick the one that's got the fewer. Whatever one's the smaller amount, pick that one. So 1,200 minus 4W. And then algebraically divide by 2. Okay. So now I'm going to substitute. Does this make sense to you? If this is equal to L, you can go replace the L. Does this all look a little bit familiar? Okay, distribute this bracket out. Okay, so this stage was all the same, but now we're going to change to calculus instead of grade 11. So in grade 11, we would have figured out the vertex by doing negative b over 2a. We would have done that. Okay, that was how we did it in grade 11. But now that we're in calculus, what else could I do to get the vertex? What would be my calculus strategy? Derive and figure out where the slope is 0, right? Because then I'm on a max. Does that make sense to you? So I'm going to go A prime equals, so derive 60 minus 4W. No, wrong. 60.
Isn't it 600?
Oh yeah, I missed a 0, so 600. 600 minus 4W. That looks better. Remember last time when I was messing up, wasn't that always numbers with 6's involved? That's 6. Okay, where would it equal 0? Isolate, divide. So 600 divided by 4 is 150 meters for the width. Okay, not sure what I'm really asking here. Maximize the total area, so am I looking for area? Well, let's just work to give me the length, give me the area then. What is the length when the width is 150? What are you going to do? Give me this. 600 subtract 150. And then also give me the largest area So I could have asked you any of those types of questions. So does everybody see where I got the L after? I plugged 150 into this line. Where did I get the area from? I just times these two numbers, length times width. Or some of you might have plugged it into this line. Do you see how that would do it too? Plugging W150 in here gets you area, or multiplying those should get you area as well, right? So negative b over 2a also would get you 150, right? Negative b, so negative 600 divided by 2 times a. That was what we did in grade 11. So you can see how it would have been the same. Okay, but now we're using calculus. Okay, the revenue question. So revenue equals the price times the people. Remember, we're setting something up like that. When you're making money, it's your ticket price times how many people, if you're doing like a concert. Okay, I always set up my two blank brackets like this, and then I start reading. If you sell tickets for 10 bucks, then 1,200 people come. A survey indicates for a reduction of 50 cents, ticket price gets reduced by 50 cents. Make sure you make that a decimal, right? 50 cents. Then 100 more people would come. And what do you need? Also, a variable, right? So if you change this a few times, this would have to change accordingly. Okay, go ahead and give me the FOIL of that. FOIL it. We'll see if we get to the same. My grade 11s are doing this right now and having a test on it. Okay, so the grade 11s would vertex it by negative b over 2a. That was what they would do. But we're going to calculus it. So derive and then figure out where the derivative has a tangent line slope of 0, right? Because that's what a max would be. So deriving would be what? 400 minus 100x.
Marcy, if you derive the 12,000,
It's 0.
yeah. Oh, sorry, I was looking at it.
Right?
Yeah.
Yeah. And then the 400x just turns into the 400. Yeah. Four. So this is the derivative. So the slope of 0 means there's a tangent line. That's a max. Okay, what's our question here? What ticket price will maximize the revenue? So what price? So what price is here? So $10, subtract 50 cents 4 different times, right? That's the x value now. So we were $10 and we decreased 50 cents 4 times. That's what the x is meaning, how many times you change the price. So we should sell tickets for $8. Okay, does that make sense? Remember all these things? So the top and the bottom steps are all the same. This is just the new part, which is the derivative, right? How many people right now think this method is actually easier than what we did in grade 11 with the negative e over 2a? I'd say it is too. Or because you're smarter now, maybe it just seems easier too. Okay, the sum of two numbers, I'm going to just go a plus b is 18. Maximize the product of the first number multiplied by 3 times the square of the second number. Maximize the product of, did I write that right? The first number multiplied by 3 times the square of the second number. Okay, this is the same as the area problem, exact same. So here I'm trying to get a quadratic, but I can't put in letters A and B. So I'm going to make an isolation to substitute in there. What do you want to do here? Do you want to replace A or B?
A.
For sure A, because if I replace B, then whatever I'm doing, I'd still have to square it, and that's not as easy as just replacing A, right? So A equals what? Isolate it. So A equals 18, subtract B. Now replace that. I'm just going to go P equals to be like product equals. Okay, finish it out. You can do this on your own. Distribute, derive, 0. Okay? Okay, so this FOIL, there's your FOIL, 54b squared minus 3b cubed. Derive. So there's my derivative, and then we're always saying, well, where is the derivative 0, which means the tangent line would be a max or a min. This is a GCF factoring, so b equals 0 or b equals 12. Those were the results of our factoring, but this gets eliminated because the question says I need to have 2 positive numbers. Okay? So obviously having something with a 0 is not going to give me a max product. So the numbers are 12 and what's your other number if the first, or if B is 12? A is, let me go back to that, and it would be 6, right? 12 and 6. Okay, the last one is your favorite, grade 12, pre-calc. Am I going to have to make this again? Do you remember? We had a paper in grade 12, and then we cut out corners. Remember that? And then once my corners were cut, I could fold and make a little box. Remember that one? That question? Okay, so we're making this box. It's a 16 by 16 paper. And when we cut, we just cut a little X square out. Okay. What is the dimension of this side once I cut? Remember, I cut a slit off this side and this side. So this is now, do you remember how to do that? 16 minus 2x. Because I cut off some x on this side and an x on this side. This is also 16 minus 2x. Obviously, if your paper lengths were different, that would be different. And then what happened to the dimension when you folded it up? What was the height dimension? Just x, because you flipped the x amount up. Okay, so we're trying to maximize the volume. Length times width times height. I think I'm going to rewrite that squared, if that's okay with you. Okay, I'm gonna just recap to you what we even did in pre-calc in grade 12, because we never figured out the max volume. We estimated. This is what we kind of did. We said this had an x-intercept of 0. This has an x-intercept of 8, right? This bracket, I would need an 8 in that bracket. Do you remember me graphing my cubic with a bounce at 8? Does that ring a bell? And all we did was we estimated that, and then I said just plug in something in between, like a 4. Just plugging in a 4, and then we estimated it. But we never actually knew how to figure that out. But now we can, right? Okay, here we go. Derive. Let's do a product. And we're also going to have to do a chain on this. Right? Okay. So 2 of the units to the 1, you don't have to write that, but 2 of the units to the 1, attach u prime. So what's the derivative of that unit? Just -2, right? All of that was f prime times g. See my breakdown? F prime was a chain times the original g plus the original f function times, what do you get when you derive the g part? 1. So that will be easier. Okay, let's put these things together. -4x. So I'm going to put the not bracket stuff together. I'm going to put those 3 things together. That's okay, you see it? -4x. Okay, can you think about how to square this binomial? Can you give me the FOILed expansion? Oh wait, what am I doing? I got my squared in the wrong spot of my bracket. Don't follow what I just did. I was going to say that would look weird. Got my squared in the wrong spot. There. 16 minus 2x squared. Give me a FOIL on that. 16 times 16. Is that 256? So to do it, are we all the same? 256 minus 64x plus a 4x squared. That's good. Okay, let's distribute that, start collecting stuff. Eventually this will look a little bit better. Okay, I'm done simplifying. Are we good? Are we matching? 4x squared minus 120?
Wouldn't it be
Did I,
8x squared?
on which part? Where?
Distributing the negative 4x times negative 2x.
On this line?
Yeah.
This. This one right here?
No.
Wouldn't that be
It would be
128?
8x squared.
8x. Yes, there. Okay, so that's going to mess my whole thing up right here. Right here I made my mistake, right? Plus 8x squared. So then, is this 128? And then this is 12x squared. There. I got a match with a bunch of people now? Okay. I'm going to set that to 0. Okay, does anybody want to factor that? No, yeah, we derived it. No, we haven't derived it yet. Wait,
Do we have to derive the derivative?
no, that's right, we derived it. I'm so messed up right now. We did derive it. We did derive it. Okay, I need to solve this. Does anybody want to factor it? No, okay, let's not factor it. So what should we do? If you don't want to factor it, what else? Quadratic formula. Okay, x equals negative b plus or minus the square root of b squared minus 4ac over 2a So it was factorable. But that's okay, this was way easier than thinking of my factors. Why am I eliminating 8? Do you know?
Because when multiplied by 2, it's bigger than 10.
10?
Oh, that's a 16, sorry. my bad.
Yep, 16, but that's right. What were you gonna ask?
The brackets in your calculator around the, and the, like,
This? You need like brackets, is that what you did?
Yeah.
Did you not get the same numbers as me?
no, like, I'm trying to.
Okay, are you doing it on this calculator or a different oh, yeah. Did you know on this calculator you can go second entry and it brings it back up and then I just go back and I change the plus to minus or whatever. Then you don't have to retype it twice. Okay, so I'm eliminating 8 because what happens to my paper if I cut off 8 and 8? How much have I cut off?
All of it.
All of it. And you can't cut off all of it, right? So eliminated. So I cut off this many centimeters from each corner. Be careful if I asked you specifically what is the largest volume you can get. Now you would have to take that and plug it in, right? But I just say how much should we cut, so then that we're done. But if I say what is the max volume, that's what you're plugging in. Okay, so do you see how that's a little bit more precise? We can do more precision now with our graphing polynomials. Okay?